Hi, welcome to Data Appreciation with Chino. We'll be looking at troubleshooting and solving data join pitfalls. This is GSP 412 Google Cloud Self-Paced Labs. So we'll open our Google Cloud Console in incognito. So the first task is to create a new dataset to store our tables. In BigQuery project, we're going to create a new dataset titled e-commerce. Click on Done. Come here, create dataset. And set the dataset ID to e-commerce. Yeah. Remember to leave each and every other option at the default values. The second task we have to pin the lab project in BigQuery. And now we're going to start project called Data to Insights. First, we go to Explorer and click Add Data. We'll start a project by name, type Data to Insights. What we're going to do next is to examine the fields. Let's go to our All Sessions Raw Data to Insights. E-commerce, All Sessions Raw. The next, under the query editor, we'll click on Schema to see the fields and information about each field, which is where we are already. Next, we're going to identify a key field in our e-commerce dataset. So we want to know how many products are on the website. We'll copy this to our BigQuery editor. So our query can run. You can see our results page is 2273. So we have something similar. So next, we're going to look at distinct products SKU. Let's copy this and run in our query. Finding the count of unique SKUs. We have 1909 distinct. Next, there are fewer distinct SKUs than the SKU and product name query had before. Which is obvious. Why do we think so? So the first query also return product name. It appears that multiple product names can have the same SKU. First query was including some product name. The first query showed only, so I think that should be the first query also return product names. Now I'm going to examine the relationship between SKU and name. We will determine which products have more than one SKU and which SKUs have more than one product name. You can clear the previous query and we run it in a new. So we want to count distinct product SKUs and it's be on a table called SKU count. Let us run it. We have 493 results. So we'll look at the query result if we have product names that have more than one SKU. You can see like this, we have more than one SKU. Which product has the most SKUs associated? So let us go and look at products with the most SKUs associated. So you can see we're ordering by SKU count descending. So this is descending. So the product with the highest is Ways Women's Typography Short Sleeve Tee. Is this? Now, the e-commerce catalog shows that each product name may have multiple options, size, color, which are sold as separate SKUs. So you have seen that one product can have 12 SKUs, which, what about one SKU? Should it be allowed to belong to more than one product? Let's clear this and put in this query. Okay, our process can run. Our results are 347. So note, try replacing the string aggregate with array aggregate instead. BigQuery native supports nested arrays values. They said when we look at the query results, are there single SKU values with more than one product name associated? What do you notice about those product names? Yes, most of the product names are similar but not exactly the same. No, the product SKUs match the product names one for one. So let's see. You can see that they don't actually match product count and product name one for one. So you will see why this many to many relationship will be an issue in the next section. Let us check our progress. So pitfall non-unique key. In the inventory stacking, a SKU is designed to uniquely identify one and one only product. For us, it's the basis of our drawing condition when we look up information from other tables. Having a non-unique key can cause serious data issues. Write a query to identify the product names for SKU, this number. Let us use this query. Let us run. So these are our results. So the question is asked, what do you think about the product names? They are exactly the same, not really. They are mostly the same except for a few characters. So you can see dog frisbee, 7-inch dog frisbee, Google 7-inch dog frisbee blue. So they're not exactly the same, so they are mostly for some characters. So it looks like there are three different names for the same product. So we're going to join the website data against our product inventory. So that's what we're going to do next. Let us take the query. Run our query. So we have one result. So this SKU is unique. How many dog frisbees do we have in inventory? If we go back to this, so I think we should go back to where we had three results. 7 dog freebie. So we had stock level. It's 154. So we had to join Pitfall unintentionally many to one relationship. So we have two data sets, one for inventory stock level and the other for our website analytics. We have to join the inventory data set against our website products. So let us have a new query. So what happens when you join the website table and the product inventory? Will you have an inventory stock levels for the product? There is no, there is no inventory data, but the join did not work. Yes, the inventory data looks fine. Yes, the index level but stock level showing three times for one each record. So this is what we have. So the next thing is we're going to expand our previous query to simply sum the inventory available by product using this. So let's have a new query. Okay. So by product, we're having a total of 462. So the doc should probably showing a stock level. You know it is now at 464, 3 times 1 for each record. So this is called an unintentional cross join. Let's check our progress. The next we're going to join Pitfall solution using distinct SKUs for joining. So we gather all possible names into an array using this. So let us run. So selecting product array create it as push all names into array. So now instead of having a row for every product name, we only have a row for each SKU. If we wanted to deduplicate the product names, we could even limit the array with this query. Let us see. Okay, okay. So let us run this. We have 1090. So how many records were returned? All 1909 SKUs. So but our answer is 1090. No, just 1090. It seems 819 SKUs were lost during or after the joining of datasets. We'll investigate by adding more specificity in our fields. One SKU column for each dataset. So you can see selecting the extent website product SKU as website SKU. So we're going to have this as our column, a field, inventory SKU as inventory SKU from our data set as website, joining to our data set product as inventory on website products inventory is called inventory. So let's go ahead with this query, see if our results will be different. It appears SKUs are present in both those datasets after the join. For those 190 records, how can we find missing records? So let us look at our possible solution. We'll select distinct website product SKU as website SKU, inventory SKU as inventory, on website product SKU is equal to inventory. So let us see. We're using a left join now to return all the original 1909 websites in our results. So many versions are null, true or false. It's true. How many SKUs are missing from our product inventory set? Write a query to fill the null values to filter the null values on the inventory table. How many products are missing? The answer is 819 products are missing from the product inventory sheet. So we'll clear the previous query and run to confirm using one of the specific SKUs from the website dataset. So we have there's no data to display. Why might the product inventory dataset be missing SKUs? So we have some SKUs critical products that do not store. Old products we sold in the past website, others are no longer offered in current inventory. There is legitimate missing data from inventory and should be tracked. So it's not all products. What could it be? So some SKUs could be digital products that we do not store in the warehouse inventory. That's interesting. Okay. Now about the reverse situation. Are there any products in the product inventory data set but missing from the website? Write a query using a different join type to investigate. Remember, some SKUs could be digital products that do not store in the warehouse inventory. We're starting our investigation. There are two products missing from the website dataset. Next, we're going to add more fields from the inventory dataset for more details. Which would the delay product missing from the e-commerce website dataset? So which of these two will be missing from the e-commerce dataset? Possible answers. One new product, no orders, no sentiment score. One product in store only. Another is a new product with zero orders. Why would the new products not show up on the website dataset? The website dataset is past order transactions by customers, brand new products which have never been sold, won't show up in web value until they are viewed or purchased. What if you wanted one query that's listed all products missing from either website inventory? So this is one query we're going to use now. We have a full join on the data set. We have 821 results. You see here we have 819 results. So a left join and right join is the full join, which means all records from both tables, regardless of matching join keys, join pitfall, unintentional cross join. Not only relationship between data tables, as one to one, one to none, can return unexpected results and also significantly reduce query performance. The last join type is the cross join. Create a new table with a site-wide discount percent. We want to apply that across products in the clearance category. So let's do that. Let us go to our table. Next, let us find out how many products are in clearance. That's clearance sales. Yeah, I have 82 products in clearance sales. So we can see the impact of unintentionally adding more than one product in this discount table. Let's use the query below to insert two more products into the promotion table. So these are discounts. What happens when you apply the discount again across all 82 clearance products? We want to apply the discount across all products. Now we can see we now have 246 returned, which is more than our original table. Since there are three discount codes to cross join, we're multiplying the original data set by 3. I will complete the lab and walk through some serious SQL join pitfalls by identifying duplicate records and knowing when to use each type of join. Thank you.